Week 7, Systems of Linear Equations. In this week, we will use our knowledge of equations of lines to investigate systems of linear equations. A system of linear equations is two or more linear equations in two variables that are solved simultaneously. These systems of linear equations have many real-world applications, from finding the total revenue of tickets sold to discovering the appropriate mixture in a chemistry application. We will investigate one of these applications. Slide number 2. In this application problem, we will find two linear equations relating the revenue for tickets sold at a local aquarium. The problem states that the price of admission ticket to an aquarium is $12, with seniors receiving a discount of $3. Children under 18 years are free. One day, the aquarium took in $5,340 in ticket revenue. In this problem, we have two unknown quantities. We will let X represent the number of adult tickets sold and Y represent the number of senior tickets sold. Take a moment to think about how we can write a linear equation given the information on the price of each admission ticket and the total ticket revenue for the day. We can write this equation containing these facts as the revenue from adult tickets plus the revenue from senior tickets is equal to $5,340. Since the price of each adult ticket is $12, the revenue from the adult tickets can be represented as 12 times X. Likewise, the price for each senior citizen ticket is $9. So the revenue from senior tickets is given by 9 times Y. The equation for the ticket revenue then becomes 12X plus 9Y equal $5,340. Slide 3. Graphing the equation for total ticket revenue, we will see that this is indeed a line. Okay. The solution of this revenue equation is every point on the line. Slide number 4. Suppose we also know that 490 tickets were sold on the day at the aquarium. Take a moment to write a second equation that includes this fact. Since the total number of tickets sold at the aquarium is equal to the number of adult tickets sold plus the number of senior tickets sold, we write our second linear equation as X plus Y equal 490. The solution of the tickets sold equation is every point on a line that satisfies this second linear equation. Slide number 5. Suppose we want the solution X comma Y that satisfies both the revenue equation and the tickets sold equation. Then we want the point that is simultaneously on both lines at the same time. Graphing the lines in the XY plane, we can determine this point of intersection. If 310 adult tickets are sold and 180 senior tickets are sold, the aquarium will have collected $5,340 and sold 490 total tickets. We can check this solution. We know that 310 plus 180 equals the 490. The total revenue for adult tickets is 12 times 310, and the total number for senior tickets is 9 times 180. Therefore, the total revenue is sold is equal to 3,720 plus 1,620, which equals the 5,340. Slide number 6. This week, when considered together, the two equations of the ticket revenue example is a linear system of two equations in two variables, or a 2 by 2 linear system. We write this system using a left bracket with both the revenue equation and the ticket sold equation together. This week, we will learn various methods for solving such a system. These methods include graphing, the method of substitution, the add-subtract method, also called the method of elimination, Cramer's rule, and using various web-based calculators that use both graphing and numerical methods. Slide number 7. The solution of a linear system of during this week you will also become familiar with several vocabulary terms. The solution of a linear system equation is all points x, y that satisfy both equations simultaneously. For a 2x2 linear system, the graphs of the equations are lines, and the solution to the system is all points that are on both lines at the same time. For linear systems, there are 3 possible types of solutions. Type number 1, a unique solution. That is, there is one point x, y that satisfies both equations. In this case, the system is said to be consistent, and the equations are independent. Type number 2, no solution. The system is said to be inconsistent. Type number 3, an infinite number of solutions. Since solutions exist, the system is consistent, but with an infinite number of solutions, the equations are said to be dependent. Slide number 8. The following are examples of 2x2 linear systems of equations. Using the terminology of the last slide, take a minute to see if you can identify which system is independent, inconsistent, and dependent. In the first graph, we see that the 2 lines are parallel. That is, the 2 lines never intersect. In this situation, the system of linear equations has no solution. The system is inconsistent. In the middle graph, we see that the system of linear equations has produced the same line. This means that any point that is on one line is on the other. That is, any point on this line is a solution to the system of equations. In this case, there be an infinite number of solutions. The system of linear equations is dependent. In the last graph, we see that the system of linear equations has one solution where the 2 lines intersect. The system of a linear equation is independent. We will see more examples of these throughout the week.